Hello, my name is Armando Darias. Today I'm going to be speaking about a very interesting topic, which is how X-ray radiation affects matter, which in this case, the matter is your body, and the effect produced in tissue by radiation. X-ray can interact in 5 different ways: photoelectric, Compton scatter, coherent, pair production, and photodisintegration. So basically the first interaction that I'm going to be covering is the photoelectric interaction, which basically is when you're going to x-ray a dense bone of the body, like the femur, maybe the pelvis. What's going to happen is that the x-ray photons from the tube are going to come in contact with the K shell or the inner shell electron, which will then exit the inner shell electron out the atom, which will become the photoelectron, which in this case could be very dangerous due to the fact that it is energy and matter, that could cause ionization within the body. An animation of the X-ray photon coming into the atom and ejecting the inner shell electron out of the atom. And you'll see here that it will be replaced by one of the outer shell electrons. So the second interaction we're going to be speaking about is the Compton scatter. So basically what the Compton scatter is you're going to have the X-ray photon here coming from the X-ray tube, coming in contact with the outer shell electron, which is going to be leading to a scattered photon, which basically is our number one enemy, due to the fact that it is the radiation absorbed by the radiographer, which leads to the radiographer using lead aprons. Another fact about the scattered photon basically is that it comes out with less energy than the primary beam due to its longer wavelengths, as you can see. It is also absorbed by the image receptor that could lead to fogginess in the image, and basically the scattered photon is going to be 1/1000th of the primary beam, and then as well as the electron that is exited by the primary beam out of the outer shell is known as the recoil electron. So this is an animation of the scatter interaction, and you'll see here when it comes in contact with the outer shell electron, knocking it out of the outer shell, which will be known as the recoil electron, and then here you see the scattered photon exiting the atom. So the third interaction that I'm going to be speaking about is the coherent interaction, which is also known as the unmodified scatter or the classical scatter. So basically, you're going to have the primary beam that comes out of the X-ray tube that could be polyenergetic, which means it could come out at different strengths. But when the strength of one of the beams reaches 10 kVp that comes in contact with the matter, it could cause two types of vibration: Thomson, which is the vibration of one single electron, or Rayleigh, which is the vibration of the entire atom. In this animation, you're going to be seeing the coherent interaction by Thomson, which here you get the 10 kVp beam, which causes this electron to vibrate. So this is the coherent scatter, also known as the unmodified scatter. It's known as the unmodified scatter because the wavelength in the incident photon and the scattered photon is exactly the same. There is no change. But there's two types of coherent scatter, which is coherent scatter by Rayleigh, which is when the whole atom vibrates just like this. And there's also coherent scatter by Thomson, which is when one single electron vibrates just like that. So the fourth interaction I'm going to be speaking about is the pair production interaction, which is only used in nuclear medicine due to the fact that diagnostic X-ray will only go up to 150 kVp. This goes up to 1.02 mega electric volts. The 1.02 mega electric volts are going to come in contact with the nucleus of the atom, which will then create an antimatter. It's going to cause the positive charge positron and a negative charge negatron. The positron will come in contact with a negative charge electron from the body, which will then cause two X-ray photons to go in opposite directions. Each X-ray photon is going to have a charge of 0.51 mega electric volts. The process of converting the energy here into the antimatter and then back into the energy is called the annihilation reaction. In this animation of pair production, you see the primary beam hit the nucleus, causing a positron and a negatron to exit the atom. For the fifth and final interaction is going to be photodisintegration, which is basically when the primary beam from the X-ray tube with a minimum power energy level of 10 mega electric volts will hit the nucleus of the atom, which will then destroy the entire atom and just leave the nuclear fragments of the nucleus. This interaction is mostly used in electrical companies that use nuclear reactors. So in this animation, you're gonna see that last interaction, which is the photodisintegration. This is the primary beam with an energy level of 10 mega electric volts, hits the nucleus of the atom, and it basically destroys the entire atom, and it'll leave a nuclear fragment. So to recap, during this video, we learned how X-ray photons can affect matter through 5 different interactions: photoelectric interaction, Compton scatter, coherent interaction, pair production, and photodisintegration. We need to take into consideration how these interactions can affect patient dose and image quality.